This is Physics 2212 Lab 1 Charge Tapes by Camille Branch. So as introduction, the purpose of this lab. In this experiment, we prepared charged pieces of scotch or clear tape after observing their interactions with other objects that were neutrally charged or positively charged. We did an experiment to determine approximately how much excess charge is on one piece of charged clear tape. We then modeled these results in GlowScript. We assumed that air resistance was negligible, one long piece of tape was treated as a point charge, and that each tape had the same amount of charge evenly distributed along its length. And just as a preview of results, there were, we found out that there were 1.45 times 10 to the negative 7 atoms for every electron on one piece of tape. Fundamental principles. So in this lab, to calculate, what we need to calculate, we use the equation for gravitational force, which was Fg equals mass times the gravitational acceleration of Earth, and then Coulomb's law to find the electric force of one piece of tape on the other. It is the K constant times the charge of one tape times the charge of the second tape, r hat over r squared, and then we use Newton's second law, which is the net force on an object is equal to a change in momentum. When the net force is 0, all forces acting on the system cancel out. And so here we have the gravitational force acting downwards and the electric force acting upwards on the piece of tape. Experimental procedures. For a system, it's U-tape B. For the surroundings, it's Earth and U-tape A. So a piece of base tape was stuck to the table, and another piece of tape with the handle was stuck on top, then ripped off to give it a charge. And that's in Figure 1 and Figure 2. The U-tape was put near charge and neutral objects to observe its interactions. One more U-tape B, was created and hung on two objects. The U-tape A was slowly brought towards it, and the separation distance between the two was recorded, as shown in the video in Figures 4 and 5. We observed that U-tape B was repelled by U-tape A, assuming that, we can assume that they have the same charge. And then just to explain the code we did, so some of the initial conditions were the K constant, the charge of an electron, the tape mass as 0.0002 kilograms, the tape length, the tape width, and these are all meters, the gravitational acceleration, the separation distance, the length of an atom, and the scale of the arrows. So to find the force of gravity and the electric force, you do tape mass times the acceleration, the gravitational acceleration, and then you find the absolute value of the gravitational force because it should be equal and opposite. The tape charge was found by solving for Q in the electric force equation, and the electron number was found doing the tape charge divided by the charge of the electron. To find the ratio between the number of electrons and atoms, we found the atom number for second by doing the tape length times the tape width divided by the length of an atom, and then we divided the two. And then as you can see here, when it's ran in the computational model, the tape charge was 9.3 times 10 to the negative 9. It had a deficiency of 5.836 times 10 to the 10th electrons, and there were 1.45 times 10 to the negative 7 atoms for every electron on one piece of tape. Now the results, like I said before, and then the possible sources of error were inaccuracy of measurements, ignoring the effects of air resistance, and we could have been in a humid environment, which could have skewed the results. And then here are the questions. What if electrons had a positive charge and protons had a negative charge? What would that change about your observations? Really nothing. They remain the same because opposite charges would still attract and repel, and it doesn't really matter what label you give it. And why is it important to handle the charged tapes with little interaction as possible? And that's because when charged tapes encounter other objects, there's a chance that the electrons may transfer to the tape, causing it to become neutral, and this would lead to less significant results, if any. Thank you for watching.